Hello friends, welcome back to Simply Study. So in the last video I had explained about how a diode works and all the three approximations of diode. If you haven't checked that video out, I will link the same in the description below. A half-wave rectifier also uses a PN junction diode. Let's first see the definition of a rectifier. A rectifier is a circuit which converts the alternating current input into a direct current output. The simplest rectifier circuit is that of a half-wave rectifier. This is what it does. This is the input, a sine wave, and this will be the output from a half-wave rectifier. Now let's see the circuit diagram of a half-wave rectifier. The AC source produces a sinusoidal voltage. In this circuit, we are assuming that the diode is ideal and a resistor is connected to complete the circuit. In the positive half cycle of the source voltage, the diode will be forward biased and hence will act as a closed switch. Since the switch is closed as shown here, the positive half cycle of the source voltage will appear across the load resistor. On the negative half cycle, the diode is reverse biased. In this case, the ideal diode will appear as an open switch like this, and hence no voltage will appear across the load resistor. Let's now understand the waveform of half-wave rectifier. For that, we need to understand few terms such as Vin is equal to instantaneous voltage, Vpin equals peak value of voltage. As shown here, the highest value is the peak value Vpin. A pure sinusoidal signal like shown here has an average value of 0 over one cycle because each instantaneous voltage has an equal and opposite voltage half a cycle later. In the half-wave rectifier, the diode is conducting during the positive half cycle, but it is non-conducting during the negative half cycle. Because of this, the circuit clips off the negative half cycle. This kind of waveform is known as half-wave signal. The output of a half-wave rectifier is also known as pulsating DC voltage, but it is not the kind of DC voltage that will be used for electronics equipment. A constant DC voltage like battery is desired for electronic equipment, and hence to achieve this, filter circuits are used along with rectifiers. Let us now see some formulas associated with half-wave rectifier circuits. For ideal diode, the first formula is peak output voltage is equal to peak input voltage. As shown here, the peak value of the output equals the peak value of the input. Second is DC value of half-wave signal. The DC value equals the average value. For half-wave, it is VDC equals to Vp by pi. That is, VDC is equivalent to 0.318 Vp. Let us see an example. If the peak voltage is 100 volt, then the DC voltage or average value will equal 31.8 volts. Third, the output frequency. The output frequency is the same as the input frequency for half-wave rectifier. Therefore, Fout is equal to Fin. Now for second approximation, the Vp out will equal Vp in minus 0.7 volts. Let us see the other representation of half-wave rectifier. Many times, half-wave rectifier circuits are shown with transformer. This is how the circuit looks. The output of this circuit will also be the same as seen before. But here, to calculate the secondary voltage, we need to use the following formula. Here, V1 is the primary voltage, V2 is the secondary voltage, N1 are the number of turns on the primary coil of the transformer, N2 are the number of turns on the secondary coil of the transformer. So, V2 is equal to N2 upon N1 into V1. Lastly, let's see where a half-wave rectifier is used in real-life equipments. But due to full-wave rectifier and bridge rectifier, half-wave rectifier circuits are hardly used in real-life equipments. But the few limited applications are pulse generator circuits, firing circuits, signal demodulators, voltage doubler circuits, etc. So guys, that's it for half-wave rectifier. I hope you have understood the basics of rectifier circuit. Do stay tuned for more videos on full-wave rectifier and bridge rectifier coming up soon on this channel. If you find this video helpful, please give it a thumbs up and subscribe to our channel. Also write down if you have any doubts or any video suggestions in the comment section below. Thanks so much for watching. Simply Study signing off.